Hello sa lahat. Ang tatalakayin natin ngayon ay tungkol sa The Nature of Mathematics, Chapter 1. Kung napapansin nyo, maayos ang pagkakasukli sa inyo ng jeepney drivers sa binayad niyong pamasahe, di ba? Pati na rin yung sa pagbili nyo ng mga street foods. Karamihan sa mga vendors na ito ay hindi nagkakamali sa pagbigay ng sukli kahit hindi sila gumagamit ng calculator. So, ang ganitong routine transactions ay isang mathematics dahil sa nag-involve ito ng pag-compute ng numbers. So, the heart of mathematics is more than just numbers. So, ang math ay hindi lang tungkol sa numero, na kung saan ang numerong ito para sa ibang tao, ito ay walang kabuluhan or hindi masyado, walang halaga. So, di ba nasubukan niyo na rin siguro na umakyat ng bundok o maligo sa dagat. At kung titingin kayo sa paligid, mapapansin niyo ang ganda ng mundo. Yung different shapes na nakikita mo sa paligid, ang lahat ng iyan ay may kaugnay sa mathematics. So ngayon, halimbawa na lang sa mga bulaklak. If you count the numbers of petals of most flowers, di ba? Mapapansin nyo na merong ibang bulaklak na isa lang yung petal, meron namang 2, 3, 5, at 8. So kung mapapansin nyo, itong sequence of numbers, di ba, na nabuo or gaya na lang ng set na ito yung numbers of petals ng bulaklak. Na ang pattern na ito ay nadiskubre ni Fibonacci. So, sino nga ba ito si Fibonacci? Siya ay isang great European mathematicians of the Middle Ages. His full name in Italian is Leonardo Pisano. Meron ding isang German mathematician at isa ring astronomer. Ito ay si Johannes Kepler, na kilala sa kanyang laws of planetary motion. He observed that dividing a Fibonacci number by the number immediately before it in the ordered sequence yields to a quotient approximately equal to 1.618. And this ratio is called the golden ratio. And it is denoted by this symbol. Okay? So the golden ratio is so fascinating that proportions of the human, such as the face, follows the so-called divine proportion. Ngayon, tutungo tayo sa Fibonacci sequence. So, ito yung kanyang definition. So, the Fibonacci sequence is a sequence that starts with a sub 1. Ito yung pinakauna sa listahan. Pinakauna sa sequence, which is equal to 1. And a sub 2, which is equal to 2. Then, each successive term is obtained by adding the previous 2 terms. So that is, para makuha yung next term or yung next number, simple, i-add mo lang yung previous 2 terms. Ito yung, halimbawa na lang, ito yung a sub 1 means ito yung first term, second term, and a sub 3 is yung third term. So para makuha yung a sub 3, base sa definition, i-add mo lang yung naunang number. Okay? So, yung a sub 3 natin is 1 plus 1 is 2. Tapos, 2 na yun. And then, para naman makuha natin yung fourth term, yung a sub 4. So, di ba, yung first term is 1. Second is 1 din, by definition. Tapos, para makuha yung next, is i-add mo yung 2 previous term, which is 2. So, yung A4 natin ngayon is yung previous 2 terms, yung katabi niya. So, ito, 1 plus 2 is 3, and so on. Ganyan yan. So, a Fibonacci numbers is any number that occurs in this sequence. So, ito yung tinatawag natin na Fibonacci number. Okay? So, Fibonacci observed numbers in nature. So, his most popular contribution perhaps is the number that is seen in the petals of flower. So, yun yung contribution niya. So, nakakreate siya ng pattern or ng equation gamit lamang yung sa pag-observe niya sa paligid. Ito nga, a calla lily flower has only 1 petal. The trillium has 3, hibiscus has 5, cosmos flower has 8, corn marigold has 13, some asters have 21, and a daisy can have 34, 55, or 89 petals. At kung mapapansin nyo, itong petal na nabilang natin, nag-represent siya sa first 11 numbers ng Fibonacci sequence. So, isolve nyo lang yung 11. So, ito, given na yung 4. So, subukan nyo lang hanapin yung mga natitira pa kung eksakto ba dito. Okay? Hindi lahat ng petal, ba, yung binilang na petal ng bulaklak, yung ini-consider. Pero itong pattern na ito ay na-discover ni Fibonacci. Okay. So we have here the principle behind the Fibonacci numbers as follows. So we let x sub n be the nth integer in the Fibonacci sequence. So the next n plus 1 term of x sub n plus 1 is determined by adding the nth and the n minus 1 integers. So ito yung pag-follow. So itong first sentence na ito is similar siya sa definition ng Fibonacci sequence. So now, consider the first few terms below. So kung i-let natin yung x sub 1 be equal to 1 to be the first term, and the x sub 2, which is equal to 1, be the second term, and the third term is found by adding these first 2 terms. So our x sub 3 is 2. And the fourth term is adding the yung successive, yung previous 2 terms. So 2 plus 1 is 3. The sum of the third and the second term. And then, to find the new nth Fibonacci number, simply add the 2 numbers immediately preceding this nth number. So, ito sa baba. Kung makikita nyo sa baba yung pag-solve. Okay? So, these numbers arranged in increasing order that can be written as the sequence of this set. So 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. Okay? So similarly, when you count the clockwise and counterclockwise spiral in the sunflower seed head, so makikita mo na yung numerong 34 at 35 na iyong nabilang ay makikita mo sa Fibonacci numbers. Okay? Meron pang isang nakakahangang pattern at ito ay ang honeycomb. So according to the Merriam-Webster dictionary, a honeycomb is a mass of hexagonal wax cells built by honeybees in their nest to contain their brood and stores of honey. Okay. Pero bakit ito na-build na hexagonal cells? Bakit hindi squares or yung ibang shape? Ayon sa isang Japanese mathematician na si Jin Akiyama, ipinaliwanag niya ito sa kanyang isang experiment na naganap mismo sa kanyang sariling TV show. So, in the experiment, a student is asked to step on one mass made of hexagonal cells and another mass made up of square cells. Ang resulta ng experiment ay nakakahanga. Dahil the mass with hexagonal cells resisted the weight of the student, habang yung mass naman with square cells was completely destroyed. Okay? Hence, the mass made up of hexagonal cells is stronger than the one made up of square cells. Pero hindi lang yan. Meron ding isa pang nakakahangang observation. Ito ay yung population ng rabbit beginning from a baby pair of the first generation, since it takes the first generation to mature before giving birth to an offspring. So there is an adult pair for the second generation, which is ready for reproduction. So there are two rabbit pairs, the parents and the baby pairs, which of the third generation. So next, the adult pair begets a baby pair, but the previous baby pair simply matures. So a family of 3 rabbit pairs for the fourth generation. Exists, and so on. So the number of total rabbit pairs at each generation constitutes a Fibonacci sequence. So mamaya ipapakita ko sa inyo yung picture para ma-visualize nyo. So denoting by this symbol F sub n, the Fibonacci sequence of n generations, kung depende kung hanggang saan mag-end, this n is a real number starting from 1, 2, 3, 4, 5, 6, and so on. Okay, is the set of Fibonacci numbers. The set is denoted by, dapat yung may bracket. So yan yung tinatawag natin na set with, ito yung elements niya sa loob. F sub n, define naman natin yung F sub n is a Fibonacci sequence. That is of this, ito yung itsura niya. So yung F sub n is equal to this number, this sequence. So in particular, denote F sub 1 equal to 1 for the first generation, F sub 2 equal to 1 for the second generation, F sub 3 equal to 2 for the third generation, and so on. So it is interesting to point out that the Fibonacci numbers F sub n obey the following relationship. Ito yung F sub 1 and F sub 2 are equal, which is equal to 1, and the F sub n equal to F sub n minus 1 plus f sub n minus 2, where n is greater than or equal to 3. So yan, divide sila. That is, so ito, f sub n is given by the sum of two previous Fibonacci numbers. What is f sub n minus 1 and f sub n minus 2, where yung n is greater than or equal to 3. So for example, ito yung f sub 3 is equal to f sub 2 plus f sub 1. Then given na si f sub 2 and f sub 1 are equal, which is equal to 1. So 1 plus 1 is 2. So yung f sub 3 natin is 2. Okay? So it is also seen that f sub 4 is equal to f sub 3 plus f sub 2, which is equal to yung 3, f sub 3 natin is 2. Ang f sub 2 natin is 1, which is 3. And so on. So para ganito rin, kagaya din ito, para makuha yung f sub 10, so i-add mo lang yung f sub 9 plus f sub 8, which is yung f sub 9 natin is 34, ang f sub 8 natin is 21, ang f sub 10 natin is 55. So, kung mapapansin nyo, tingnan nyo lang yung yan, yung index dito. 8 and 9, 10. Para may idea kayo. So ito na yung population ng rabbit. Nag-follow siya sa Fibonacci numbers. Okay. So now, let us investigate the ratio of two adjacent Fibonacci numbers as n becomes large. So what if yung n natin, diba, lumaki pa, maabot siya ng 1,000, million, ganyan. So we have this table. So the following table gives the value of this ratio as n approaches infinity. Okay, kung makikita yung n mag-approach sa infinity, this infinity is million, billion, trillions, and so on. Okay? So ito yung table given by this formula. If our n is 3, 4, 5, up to 16 lang. Or pwede nyo rin subukan kung ang n 20, kung n ay 100. Okay? So, pwede nyo i-substitute, i-solve nyo lang sa sarili nyo. Now, note that the ratio of two adjacent Fibonacci numbers approaches the golden ratio. Okay? That is, yung golden ratio is equal to 1.618 as n becomes larger. Ba? Based dito sa observation natin. Di ba kung makikita nyo when n is 3. Tingnan nyo yung result. Diba? 2, 1.5, 1.6, up to, ito na, 1.168, up and so on. So, yung ratio daw, itong ratio na sa observation natin is papalapit ng papalapit sa golden ratio. Which is yung golden ratio natin ay ito, 1.618. 0.33988.7. Okay.